Okay, today we're starting AV2, which is perimeter of areas of similar figures. So we've done perimeter and area, now we're changing that to similar figures. We've got some vocab. Alright, we remember that similar figures are figures whose corresponding angles are congruent and corresponding side lengths are proportional. So they're in a proportion. The scale factor is the ratio of the lengths of the corresponding sides of two similar figures. So, for example, if you had a shape like this, that's 2, and then you had a larger one, that's 6, scale factor is actually going to be 3. It is old over new. That's 3. Or think of it as, what do I multiply the first one by to get the second one? So when it's an enlargement, like that one was, the scale factor is going to be greater than 1. If it's a reduction, like this one, the scale factor is going to be less than 1. So here the scale factor is going to be 1/8. 8 first shape times 1/8 equals 1. First shape times scale factor equals second shape. First shape times scale factor equals second shape. Okay, just a reminder here, it's old over new. So if the scale factor for a figure is A over B, the scale factor for its perimeters is going to be A over B. So the ratio of the side lengths and the ratio of the perimeters are the same. Unlike areas, if the scale factor is A over B, the scale factor of the areas is going to be A squared over B squared, because scale factor is in linear and area is not. Alright, the figures in each pair are similar. Compare the first figure to the second, find the scale factor, and give the ratio of the perimeters and the ratio of the areas. Well, it says first figure to second figure, but it doesn't really label. So we're going to go pink to blue. So our scale factor, let's just start there. Pink to blue. What times the pink one will get you to the blue one? So that would be 3. I got that from doing 12 over 4. Old over new. Right? Old over new. 12 over 4. The scale factor of the perimeters is going to be the same thing as the scale factor of the sides. It's going to be 3. We don't know the perimeter here, but if the perimeter of the small triangle was 10, then the perimeter of the large triangle would be 30, because we're multiplying it by 3. And then scale factor of the area. Remember, it's old over new, but it's squared. So it would be 12 squared over 4 squared. So that's 144 over 16. And that simplifies to 9 over 1. Right? Let me check that. 144 divided by 16 should be 9. Yeah, if I type it right. Yes. So it's just the scale factor squared. Scale factor of the linear sides is 3. Scale factor of the areas is 9. Alright, in this rectangle, compare the first figure to the second figure. First, second, so we're going this direction. Find the scale factor. Okay, so scale factor, we're going from 9 to 3. 1/3. 9 times 1/3 equals 3. And if you're thinking old over new, It's 3 over 9. Okay, ratio of the perimeters. I think I did this wrong last time. Ratio of perimeter. It's going to be the same. Well, yeah, it's the same. Same as the scale factor. Ratio of the perimeter is 1 to 3. No. Nope. Ratio of the perimeters is going to be 9 to 3 or 3 to 1. Scale factor of the perimeters is going to be the same. Ratio of area. So we're doing red first, then blue. 9 squared, 3 squared. So it's 81 over 81 to 9, and that simplifies to 9 to 1. So it's a 3 to 1 ratio for perimeter and a 9 to 1 ratio for area. Let's see, these figures are similar. Find the area of the other figure. So now you're going to apply area of LDPE. So this one has an area of 12. LE is 4. BC is 8. So our scale factor is 2. We multiply the red figure by 2 and we get the blue figure. So that means if we want this in ratio, it's going to be 4 to 8, which is the same as 1 to 2 ratio. So notice how scale factor and ratio are kind of flipped upside down. But we want the area of the larger one. So instead of perimeter, we want area. So we have to square these things. So it's going to be 1 squared to 2 squared, which is 1 to 4. So instead of multiplying everything by 2, we're multiplying everything by 4. So the area for our blue shape is going to be 48 meters squared. Okay, when we're multiplying to get side lengths, we multiply by 2. When we get area, we multiply by 2 squared. And the scale factor and the ratio of the perimeters. Area of the red triangle is 8 root 3. Area of the blue triangle is 128 root 3. So we want to kind of reduce that. So we have 8 root 3 to 128 root 3. Well, let's simplify those things. We can get rid of the root 3's on both of them. And let's see if what we can divide 128 by. Well, it can be divided by 8. So I'm left with 1 here. And 128 divided by 8 is 16. So this has a ratio of 1 to 16 for the perimeter and the sides. Perimeter slash sides has the same ratio. Which means our scale factor is 16. First shape times 16 equals second shape. First shape times 16 equals second shape. Find scale factor and the ratio of the perimeters. Okay. Wait a minute, nope. Back it up. That is the ratio of the areas, not the ratio of the perimeters. 8 root 3 times 16 is 128 root 3, but that's area. So that means the ratio of the perimeter is going to be the square root of that. It's going to be 1 to 4. That's our perimeter ratio, sorry. And the ratio of the sides, which means our scale factor is 4, not 16. So 16 was how we multiplied to get area, but if you were doing side lengths, you'd multiply by 4. Okay, find the values of x and y when the smaller rectangle shown here has the triangle has the area given. The smaller similar rectangle. So this one has the area of 10. X equals y equals. Well, this one has an area of 90 because it's base times height, 9 times 10. So when we changed areas, we went from 10 to 90, which is 1 to 9. So that's our area ratio. If we want to do the side ratio, we're going to square root that. So it'll be 1 to 3. So that means the pinkish shape, red shape, multiplied by 3 equals the blue shape. And if you're talking area, the pink shape times 9 equals the blue shape. So x is the easy one. What times 3 equals 9? Well, x has to equal 3. And then y is harder. What times 3 equals 10? Well, that's 10 thirds. 10 thirds times 3 equals 10. So let's check that. Does 3 times 10 thirds equal 10? Because that's base times height. All the cancels. So 10 equals 10. So our x is 3 and our y is 10 thirds. Okay, figures in this pair are similar. Find the value of the missing sides. We have two nested triangles. I like to draw these separately. So we've got BEV and SEF. Okay. The area of BEV is changed to blue is 36. The area of SEF is 12. Alright, since they gave it to me in this direction, I think we're going big to small. So that means we're going from 36 to 12 in area. That simplifies, if you divide everything by 12, 3 to 1 for area. Okay, so if we're going to do sides, we got to do square root of that. So it's actually going to be root 3 to 1. Which means our scale factor is that kind of flipped, 1 over the square root of 3. So if we're trying to find the side length of the smaller one, I needed to multiply by something less than 1. So I'm going to do 6 times 1 over root 3 is going to equal my question mark. So we can do that as a decimal. So it's going to be 6 times 1 over root 3, which is 6 divided by root 3. And I got a we'll call it 3.5. So my SF is 3.5. Now, if you get something bigger than 6, we know we did it wrong because the 6 is here, makes that 3.5 there. Okay, so that's the last one. So we're going to do more practice on these tomorrow, which is the last day before break. Today's Wednesday. But if you have any questions on what we've done so far, please bring them to the meet. I will see you there.